For this session, I'm just going to very quickly run through the basics of drug calculation. This will be very simple, but the idea is actually the process we're explaining you can use for more complicated situations. Just to recap at the beginning, it's worthwhile just remembering, typically when we're talking about drugs, when we're either talking about masses or with volumes, we tend to use SI units. And the SI units, in effect, are a factor of 1,000 different. So typically with our drugs, we'd be talking about micrograms, milligrams, grams, and kilograms. And if we're talking about volumes, we'll be talking about mils and litres. Do remember that there are non-SI units around as well. So if you start talking about decilitres and centilitres and other things like that, then that will add confusion because they're not a factor of 1,000. So anyway, just to clarify, if we've got a drug that is, say, 400 milligrams, and we want to convert that into grams, well, because it's a factor of 1,000, 400 milligrams will actually equal 0.4 grams. Now we'll just move on to the basics of drug calculations, and although I've got 3 examples which are very simple examples, as I say, it's the principles that we're using to work these out. I think the useful way is to separate it into 3 different areas when you're working out the drugs, which is starting with what I've actually got. In other words, what have I got in my ampule, in my tablet, or in my vial that I'm going to use? What does the patient actually need? And then following on from that, a calculation of what do you then give. So we're going to start off just thinking about, we've got an ampule of a drug which is 10 milligrams per mil. The patient needs 20 milligrams. And although this is a very simple example, and you can probably work that in your head, let's just think about how we do work that out, just because we will be working with more complicated ones. So the patient needs 20 milligrams. So what I'm going to do is just simply divide 20 via what I've got, which is 10 milligrams, making sure all the time that the units are the same. You'll run into real problems if one of these says micrograms and that says 10 and you just divide the two. You can't do that. So 20 divided by 10, which lo and behold is 2. So in this case, I'm going to give 2 mils of the drug. What I also think is a really useful safety step is to always think about, before you even do that calculation, just think about what would I expect the answer to be. So let's look at this next one. So next one, we've got a drug which is in a ampule, we've got 20 milligrams in 5 mils. Now the first thing you'll notice, the first difference here is of course that this is now not per mil, and to do the calculation we need to work out how much is that per mil. So I need to divide my 20 by 5 to tell me how many milligrams there are per mil. So if I divide 20 by 5, that works out at 4 milligrams per mil. And I'm going to put a box around that because that's the actually important figure rather than the 20 milligrams in 5 mils. This is where I can introduce that safety step of just getting a global figure for what I expect the answer to be. So I want to give the patient 40 milligrams. I've got 4 milligrams per mil. So in my head, I'm already thinking, well, that's quite a large amount, and maybe even because that's 20 milligrams, I already know it's more than 1 ampule I'm going to be giving. In other words, more than 5 mils. I don't have to go any further than that with mental arithmetic, but what I've got now is some ballpark idea that I'm expecting an answer which is larger than 5 mils. As I say, the arithmetic in these is very basic, but it's demonstrating how this is done. So same again, now I've worked out how many mils I've got, I know what the patient needs, so I'm going to take what the patient needs, which is our 40 in this case, and it's 40 milligrams, and I've got 4 milligrams per mil, so divided by 4, and this tells us that we're going to give 10 mils. Going back to my rough working out, I knew it was going to be more than 5 mils, and in fact actually clearly that is just twice as much, so it would be 10 mils. But as I say, it's important to understand the steps and process we're doing. Next example, I've now got an ampule which has got 100 milligrams in 2 mils. So same again, I need to get that down to how many milligrams there are in a mil. So 100 divided by 2 means we've got 50 milligrams per mil. Again, I'm just going to box that round because that's the important number, not that. Patient needs 75 milligrams. Rough mental working out. Well, 50 is per mil, so I know it's going to be more than a mil. So that's just my safety step reckoning. So then I've got the patient's going to need 75 milligrams. I'm going to divide that by what we've got, which is 50 milligrams, and that will tell me that this patient needs 1.5 mils of the drug. Does that fit in with my simple safety check? Well, yes it does, because I said it was over a mil, and actually you can already work out it's going to be less than 2 mils, so I already knew it was going to be somewhere between 1 and 2 mils, and that's 1.5 mils, so it fits in with that mental model. Finally, just a little bit about percentages, because a lot of the drugs that we often come across, like the local anaesthetics, they're often represented by a percentage. So how do we change that into milligrams simply? Well, there's a very simple cheat. Just think of any drug like 1% Marcaine, 1% lignocaine. So we're going to think about something that's 1%. And we've got somebody that's been prescribed, say, 20 milligrams. So how do I get that percent to it? Well, there is a technical way to work it out, but my cheat is just basically, when you write it down like that, a 1 with a percent, just think of that as being together, and therefore that is actually 10. So 1% equals 10 milligrams per mil. So if I needed to give the patient 20 milligrams, well, if I had 1% lignocaine, I want to give them 20 milligrams, then I'm going to give them 2 mils, as it was. Once you can remember that, obviously if that was 5%, if that was 0.5%, you can work it from there. So as long as you can remember what 1% is, you can take it from there. Final thing, just think about calculators, using your phones and whatever you've got access to. Don't be worried about doing that. It's a good safety step, as is getting other people to check these drug calculations for you. Obviously, if you're working with a COVID-19 patient, you're not going to have your own mobile phone on you. But even if it's a case of writing down on a paper or having access to some calculator in the environment, these are all things that will help you. Anyway, I hope that was a useful summary. Thank you.